Hello and welcome back. This is the second chapter of the video series of the Internet of Things in the production. And this episode I will talk with you about what happened the last couple of days. I talked with Engel, manufacturer who is producing our injection molding machines, and I got the data from them what their standard IoT devices can provide on data, and we will have a look at that. And I also talked to Bosch Rexroth and Martin Grune from IIOT, which is a software company, and we discussed what would be the first steps to generate a minimum viable product with the ctrlX core to bring our machines into the Internet of Things. Well, I talked to Engel, and they told me that they could retrofit one of our machines instantly, more or less. It is the Victory 200, which is built in year 2013. And they said that they just need to update the software or install a license, and then we could hook up with the machine. And if you look at the machine, you instantly see that it's a new one, and also if you look inside the control, you see that there is like a CAN bus connection or an Ethercat something, and also an USB connection. So I think they will open up the port for the Ethernet, and then you can just connect to the machine with the software, with the Engel software you install on a server or on your computer, and can read the data. Which data I will discuss with you later. We will look at the data that Engel will provide. But first things first. Engel then told me that they have like for the younger machines like 98, 99 and 2000, there would be an option for a hardware update and then a software license to retrofit those machines. And also if you look at the control of these, you see that it's a Keba control. And there is already a debug connection, and I probably think there is some kind of module they just slip in there and then connect with the rest of the machine, and then you can have an Ethernet connection with the machine. And for the three oldest of our machines, like 87, 90 and 91, it's unfortunately not possible to get them into the Internet of Things. Well, not for Engel, because they say they don't have hardware support for it. Well, if you look at the control, you see this pretty old cards, electrical cards or boards. You slide in here with the connecting PCB at the back. Pretty awesome technology for that age. I love those things. But yeah, well, of course you don't get easy data out of this. I can understand that. But for that I was talking with Bosch Rexroth and Martin Grune from IIOT, and we decided on the KPI, on the key performance index, key performance indicator we would like to use first, and this is also described very nice in this book, Smart Manufacturing or the Internet of Things in Production. I don't know if it's available in English, but it's a pretty good book by Alexander Sinsel. And he describes this parameter very well here. Sorry that it's in German. And we are talking about the OEE. It's the overall equipment efficiency indicator. Let me make it a little bit bigger. Of course, there are the formulas and everything. But a picture says more than 1,000 words, right? So what we have is we have the whole production time of, or the whole I don't know how to translate Betriebszeit. The whole time the machine would be used or blocked during a production, and the OEE, the overall efficiency, is the percentage in which the machine produces good parts. So this is the value we are looking for, and to get that we mostly need two things. If you look at the formula, we need the cycle time per unit, and we need the good parts, and this is divided by, or the whole thing here is divided by the Betriebszeit, production time, and we will see if we can get these two data points. And for this I was looking at the Ingo documents, and this is for example the CC100 machine, and the parameters we would need are marked in green, like here it's called Schusszähler, Ausschusszähler, and cycle time. So this is the overall parts produced, and this would be the bad parts. So the good parts, like the green one here, would be the overall parts minus the bad parts, and the cycle time is per part. So if we look at all the parameters, here are 67 parameters, they're almost all about the specific production for this one part. So we really don't need them all. It would be nice if we could grab them and store them somewhere or use them later, or you could really improve product efficiency, I think, if you have all those parameters. But for the first step we don't need them right now, and the same is here for the CC200 control. We see a lot of parameters, but actually we just would need 3 of them, like a total reject counter, the cycle time, and the shot counter. And the same is for the CC300. Interesting thing about the CC300, if you look at it in comparison to the CC100, then you immediately see that there's a lot more parameters you can get from the machine, where you see how the development in the last years went on these machines, and how important these connecting to the Internet of Things or to a network is already. So, but same here, we just need 3 parameters, like rejected parts, part count, and the cycle time. Well, and how we will solve this all with the ctrlX core, we will discuss in the next videos, but maybe you can already imagine. Well, now we already have almost everything we need for our first trial. We need to get the cycle time and the production counter, and I think this could be pretty easy done with this one. This is an inductive sensor which detects metal, and if there is no metal, yeah, there is no signal. And so with that we could just every time the form opens and closes, we just get a signal, and we get the time between it, so we have the cycle time, and we will try with this. So the next video in the next chapter will be all about this hooking up of the sensor, connecting it to the ctrlX core. Of course there is an additional digital I/O we need to get it hooked up with the ctrlX, and well, we will see how it works, and stay tuned and share and like, please. Thank you.